Number one, we are using a midpoint Riemann sum. So there's a couple ways to look at this. What does 1 over x look like graphically? It's this thing, right? Something like that. And we're looking at it from 1 to 3. And we are cutting it into what? 4 subintervals. So how wide is each subinterval? 0.5. So these points would be 1.5, 2, 2.5, right? Now, I want a midpoint Riemann sum. So the first thing I have to notice is what is the width of each rectangle? So we're going to say 0.5 times, what is the height of the first rectangle? Well, am I going to use the x value of 1 or the x value of 1.5 to find the height? Neither. Neither of them. If I use 1, am I using the left? Am I finding left or right? Left. If I use 1.5, I'm finding the right. I want the midpoint, so which value should I be using? 1.25. So I'm just going to write it like this right now. I'm going to say f of 1.25. Okay? I guess so 0.5 times that. Plus, how wide is the second one? 0.5 times f of, what's the point in the middle there? 1.75. Plus, the width of the next one is 0.5 times 2.25. Plus 0.5 times 2.75. Or sorry, I said that wrong. F of, right? F of 2.25 plus 0.5 times f of 2.75. And so we plug those values into our 1 over x and find whatever those values are. And it gets kind of gross, I admit. What can I do to simplify this a little bit? Because they all because they all have a width of 0.5, we can factor that out, right? So we could say 0.5 times, I guess you could say 1 over 1.25 plus 1 over 1.75 plus 1 over 2.25 plus 1 over 2.75. What was the answer on that? 1.090? $1.089. What did I get?
Yeah, that's what you get when you put it in.
Okay. All right. So that's number one. Number two. Are you guys okay on number one? Okay. Number two, we did this briefly yesterday, and we're going to go over that FRQ in a minute. But if I want to know when G is increasing, let's interpret that. G is increasing when? When? One or the other, not both. When G prime is positive. Okay? So we have to figure out what G prime is. Now in this case, it gives us G. So G of x, let me write it down, equals the integral from 2 to 2x of, what does it say? T squared minus 3t, and then dt. So what is G prime? What do I do to find the derivative of G if it's an integral function? How do I take the derivative of that? What did you say?
2t.
No, time out. We are taking the derivative, right? That means I have to take the derivative of this side. I'm not taking the derivative of this. I'm not taking the antiderivative of this. I'm taking the derivative of the integral. What do I do with that? Why do I not have the attention of you guys? Focus. What do I do to take the derivative of an integral? Kind of, except for what do you notice about the upper function? So we have to take this value and do what with it? Not multiply it. You're going to plug that in to t. So what's that going to say? 2x squared minus, and then all of that times the derivative of that. That's the chain rule. You guys okay with this? Let's simplify this a little bit. G prime of x equals 4x squared minus 6x, and then times 2. And then I'm going to factor that. So Take out a 2 and an x, so we get 4x times x minus 3. Well, I have the 2 already out here, so. Are we okay with this? So what am I looking for when g is increasing? So we got to figure out the critical point, so we set this equal to 0. So when does this equal 0? 0 and 3 halves? No. Something's wrong with this.
Yeah,
Something's wrong, right?
call her.
This should be 2x here?
Oh, yeah.
Yeah, okay, that's why. See, I knew the answer from earlier, but yeah. So x equals 0 and x equals 3 over 2. So now we set up the number line 0 and 3 halves. This is when g prime is 0. So let's plug in a number over here like negative 1. What do we get? So positive there. Plug in 1 there. You get positive and negative. Plug in a 2, so that's positive and positive, so positive. So g is increasing when g prime is positive. Therefore, you could say for all x within negative infinity to 0, and actually that would be closed interval. 3 halves to infinity. Are we okay with that?